Hey everyone, just a quick video, just going back over what we talked about this morning about how the blood volume changes when a patient is dehydrated and how you can actually quantify that by looking at their hematocrit and their hemoglobin values changing. Just some extra terminology I've included in here is the patient dehydrates. Something that we can refer to that as is intravascular volume, or the volume within the vessels is decreasing. So that's just some common terminology that we see in healthcare. Intravascular volume is decreasing as the patient dehydrates. And this is an example of what we looked at in class this morning with the test tube, with the blood volume. It's been centrifuged, separated, and we can actually visually see that the plasma fluid as measured is 55% of the blood volume, and the hematocrit is 45%. That's where your formed elements are, majority being your red blood cells. With a normal red blood cell count, you'll have a normal hemoglobin count of 15 grams per deciliter. So when the blood is separated, we see the 55% plasma, and I wrote fluid in here just to remind us that a lot of that is water, about 91% in what the book says. The 45% remaining is your hematocrit. The 45% over 15 grams per deciliter, if we just look at it numerically, that's a 45 over 15, or a 3-to-1 ratio. And that's just normal. So this would be an example of a patient who is normovolemic. All right. Should a patient dehydrate? When they dehydrate, again, their intravascular volume is decreasing. You'll see that as a comparison, their hematocrit, although the value increases, the amount of formed blood cells actually stays the same. So when we lose the fluid, even though the formed element stays the same, it actually becomes a larger percentage of what is in that test tube. So as the patient dehydrated, the plasma fluid went from being about 55% of the test tube to now, and just in this example, only being 40%. The remaining 60% now is composed of those formed elements, majority being the red blood cells. So if we take that, that would give you a 60% hematocrit. And with the red blood cell count not changing, the hemoglobin value would still be the same at 15 grams. 60 over 15 becomes a 4-to-1 ratio. So whereas a normovolemic patient will have a 3-to-1 ratio of hematocrit to hemoglobin, when a patient dehydrates, their intravascular volume decreases, they become hypovolemic. Write that in here. Hypovolemia shows that ratio increasing. So fluid volume down, ratio increases.